This is an interview with Sebastian Bürgel, the founder of HOPR. HOPR is a private data exchange infrastructure. Specifically, they allow blockchain projects and protocols to enable and enact more private methodologies for transmitting information. One of the things that blew my mind, I learned in this conversation, was if you have a wallet in your desktop, a decentralized wallet, your wallet has to query the server or the node to figure out how much money, Bitcoin or whatever you have in your wallet, is in the wallet. And so the server knows your IP address, which is effectively your digital identity. And so realizing this, Sebastian created HOPR, which is a network infrastructure that reroutes that pathway to the server, to the node, and makes it much, much harder for other people and servers to recognize which IP address you're on, which is very, very important because, assuming you're a whale and you have hundreds of millions of dollars in your account, like I do, just kidding. You don't want that tied to your IP address publicly on chain. So we talked about this example, other examples, his history prior to HOPR. He's a PhD in something completely unrelated to crypto that I found fascinating, and much more. So I hope you enjoy this conversation. Here is Sebastian Bürgel. All right, Sebastian, I'm pleased to be chatting with you. I love what you're working on, and I love your background. I'd love to learn a little bit, maybe to set the stage. You got a PhD in Caltech, as we were chatting about a minute ago in the pre-show. What were you studying in your PhD, and how did you get interested in this area?
Yeah, so first of all, my PhD was from ETH Zurich. I was at Caltech for my master's thesis. That was before. But actually, yeah, that was prior to joining the crypto ecosystem. I did a degree in microengineering, so microtechnology for biomedical applications, actually. So how can we use basically this exponentially growing tech that's been going on, called Moore's Law, right, for a couple of decades? How can we use that in very different settings now that we have this technology basically available? So yeah, that was my my PhD, working with cell cultures like cancer cell lines and microdevices for some human parasites. Pretty interesting stuff. But then eventually the crypto bug hit me, and I knew that was the thing for which I had to jump.
Yeah. So at the time how did microdevices and the cellular component to it, or multicellular spherical model organs utilizing electric impedance spectroscopy? Translate that for me?
Yeah, so basically the idea is, if we're studying cells, we typically tend to do that with a microscope. And that is not just labor intensive, but many times it's also subjective. So what we're trying to do is come up with objective means of studying cells and cellular organisms in a highly automated fashion, right? So automation is kind of something that I find always exciting. So automating basically research for kind of new drug compounds to cure new diseases that we can't cure so far is something that can tremendously benefit from technical advances and using automation and miniaturization.
And so what an example of this would be some sort of AI or computer image recognition of the different movements of cellular behavior?
Yeah, you could use that. Actually, one project that I worked towards the end of my PhD and during my postdoc that I eventually quit to get into crypto, what I worked on was actually we can by now simulate kind of a human body on a chip. And that's kind of mind-blowing, right? So you can have like these teeny tiny like spheroids that are simulating an organ, right? So you can have a micro liver, you can have a micro heart, you can even have like a micro brain, even if that sounds really weird. And on that, you can simulate the effect of new substances that you study without having to do animal experiments. So animal experiments both have like ethical concerns, as well as being actually, pretty shitty because animals don't happen to be all the same. So
Mm.
how can we do better than this kind of gold standard of animal experiments using technology?
Mm.
That is an
And when
example of how we can use that.
and when you say they're on the chip, do you mean that they're computationally represented by an algorithm that's encoded on the chip?
No, in this case, when I say chip, I'm not talking about the typical silicon chips, which you might know from your CPU or your GPU, right? But I'm talking about like a micro device, which have like some little vials and some little channels in it, and like fluid, just like the blood flow in your body, right? So it's really a micro device that has microscopic structures harboring, some organoids, or even sometimes we studied some parasites in these devices. And then in an automated fashion, you can use that device to perfuse it with substance or with like a substitute for blood. And then you study, well, how does this evolve? For example, toxicity. Typically, when you come up with a new compound, right, it kills cancer, great. But if it also kills your liver, that's not so great. So
Mm.
that's a typical example of things that we will study.
Hmm. And how did you feel about the industry, or just maybe even the subspecialized field towards the end? Were you feeling frustrated, or where there wasn't maybe an obvious means to make progress in this area, or do you feel
Honestly,
very
it was.
optimistic?
I felt kind of optimistic, but one thing that I found very interesting, kind of coming into crypto, then also, I guess we're going to talk about that in a minute, but is the signal to noise, right? I studied a field that almost nobody knows exists called microfluidics,
Mm.
and then there's so few people who know that this field exists, and yet I think there's some great discoveries that are being made and applications that come out of it. So yeah, but it's like very much under the
Mm.
surface. So it's not that I
Mm.
left it because I was like really frustrated about it, but because I felt like there was something that is, not just a great research field, but really a once in a century or even more scarce opportunity with crypto. And
Do you feel that? Yeah,
that's why I eventually
yeah, make
said,
the change.
I'm going to leave that field behind and going to move over.
Do you feel that there is, crypto now, especially in 2022, but even really starting in 2017, became very widespread, at least the conceptual knowledge of it, like Bitcoin and Ethereum launched at about that time. And so there was a developing consensus, no pun intended, around the rigidity, security, potential in the technology, in the way that the technology is structured, and a lot of people are attracted to that, rightfully so. In 2012, it was a different world, and I wonder sometimes whether what's the Bitcoin in 2010 or 2011 today, and something like what you're just describing feels like the kind of thing that could have the breakthrough potential, where it's like, hey, we've discovered this piece of gold in this tiny little corner of the world, and it takes a visionary to take the understanding of the technical capabilities and potentials and then translate it into an actual viable use case. Do you feel like I just to close the loop on this, do you feel like there is that kind of breakthrough potential in the area you studied?
Honestly, so the area I studied has been in heavy research for decades. And what came out of it, compared to crypto again, is not so much, right? Maybe what people know of microfluidics is maybe a pregnancy test, right? So that's basically applied microfluidics, and that's a little bit, that's quite down to earth.
Hey, that's a very, very useful test.
I know, but it's at the same time I feel with crypto being such a new thing, what I guess by
Mm.
comparison really fascinates me is, all technologies that mankind has seen pretty much came out of universities, right? So the thing that I studied, all these inventions that come out of physics, chemistry, biology, you name it, they come out of decades, sometimes century of publicly funded R&D. And in crypto, it's
Mm.
quite the opposite. So crypto is coming from this weird nerd corner. We actually don't even know exactly where it comes from if you count Bitcoin as the starting point, really. And when I started being professionally active in crypto in early 2016, it was really that academics would not even take it seriously at all. So I feel that the starting point and this momentum that crypto has reached now is very different compared to many other technical advances that mankind knows, because it comes in a very different trajectory. And in quite some areas, researchers are still fighting with that, because many areas of crypto are still not taken serious as serious research. So I know, for example, some researchers working on MEV. It took them quite some time for MEV research. So like some nuance of crypto for the ones who are not familiar with it, some value extraction scheme was not being taken too serious by academic literature at first, because it had to draw this connection. Normally there is an inherent connection, because some research builds on some other research, then an application comes out that builds on all this huge tower, right? But in crypto, it was somehow different. Of course, like there have been early cryptography research papers already in the 90s working with decentralized forms of money, but none of them had really made this breakthrough of crypto and everything that followed. So we really had to bring that stuff and carry it back into universities. And that's kind of weird, never happened before, really.
It's kind of surprising you say that, because in my mind, I think of crypto as being uniquely attractive to, but maybe not utilized by or appreciated by academics. It seems like we're in a state now, and have been really for 10 years, of looking at the math, the algorithmic structure and data system structures as being the source of innovation in the space. Like by comparison, I look at, now the Web 2 world of technology being maybe, late 90s, 2000 to the next 5 or so years was really when the heavy tech was developed, like the browser, the OS, the hardware, and then the platforms came out on iOS, Microsoft, and Google, and you could then have the tools to unlock creativity. And then it's like, you don't need an academic background. You just need to be able to spend a few years building code, designing things to then come up with the ideas you have. Like Uber was not launched by academics, and just about every other large company. But today, like level 1 protocols, level 2, I mean, the number of people I talk to that have an academic background is way more than anyone in the Web 2 world. And so maybe that's changing. I mean, maybe academics realize that now.
I mean, there's also, just to maybe clarify this, there's been tremendous achievements that do come out of academia that did merge into crypto, right? So I would say the zero knowledge field, for example, is building on decades and decades of theoretical maths that finally came to a point that it is practically useful, right? And that is driven entirely and on the forefront of mathematics research for decades, right? And that comes into crypto now, and that's absolutely phenomenal that we see this in production today. But if we look at this consensus layer, right, at this huge leap that Bitcoin took, that is something that is absolutely fundamentally new. So there's been like a bunch of different classical consensus algorithms in computer science literature been before, but the version that Bitcoin introduced with this proof of work, to have basically a fault-proof consensus in a decentralized network, is something that has never seen before, that the academic world has never seen before. And that also hasn't been published in an academic paper in that form, right? So that was kind of weird. And it took really still quite some years then from the Bitcoin white paper coming out until there was actually academic research on these decentralized networks. So it was really still quite some years before there was research done on these things that were already in production, right? So Bitcoin was a production-ready system of, I don't know how big the market cap was back then in these early years of 2011, 12 or so. But it was some like pretty valuable system that was used in production without building on scientific foundations that brought it out. And that's a tremendous achievement for this community of weirdos out there.
Yeah. How do you feel about the academic world today? Do you feel like it is aimed is trending in a direction that's more productive? Do you feel like it has the, I guess, societal support maybe in Western countries that they're able to utilize their interests, have enough resources to add value in society in an efficient way?
Yeah, honestly, I'm a little bit in two minds about it, because on the one hand, I do see that academic research brought incredible advances to mankind, right? And that is absolutely, nothing in diminishing that. On the other side, I see that academic research is kind of lagging several decades in, how do humans actually collaborate? And by contrast, I find it absolutely refreshing and phenomenal how people in crypto do research these days. So, in this academic world with publishing and established papers, right, having these journals and these editors, which are basically just completely pointless institutions that extract value. If you're thinking about it, it's absolutely weird. How does this system work? I, as a researcher, have to write a paper that gets submitted to a journal, which charges money for it. Typically several thousands of dollars.
How much? Yes,
typical is several thousands of dollars, like between $1,000 and several $1,000s. And then this article of mine is basically their intellectual property, right? I cannot take this final form of this paper and put it, on my GitHub or whatever. Like that's not typically what you can do. And then it's published by these journals. So you can buy the journal, and universities have to buy the journal in order to access the knowledge that I, who might be from the same university, have produced, right? And that's just so weird. And then again, this mantra of free and open source software that we see not only in crypto, but I would say in crypto is a very integral component of it. Is something that's so vastly different. People innovate in the open. It's not just that you're publishing something, the result of your work is open, but people are working in the open. Like if you look at our work, you could literally look right now who's working on what task in our project. And that's not us being an exception. That's how this space rolls. And I find it absolutely amazing and very refreshing coming out of this, slow-paced environment of academic research.
Yeah, boy, it almost seems like we're coming to a head where either academics and the structure of the academic funding and deployment of knowledge process is going to go through a major revolution, or it's going to be effectively whittled down because the smartest people are not going to be attracted. It seems like the financial incentive is what drives it. If you're 20 years old or 18, whatever you make the decision to either go into academia or not, or even if you got your PhD and you're practicing, you're on your way to tenure, or you're a tenured professor, whatever level of the ladder you're on, there's competing financial incentives. You could go work for a private company or work in the open source space. And if there's enough compensation, like if you're making more money and there's enough upside in the future, it's like, well, once you lose a critical mass of smart people in academia, then how does the system stabilize? I mean, is it just... Do you see let me ask you this, what's more likely, a future where academia kind of cripples, where the smartest people leave and they move into doing what you're doing, or academia sharpens the blade, they recalibrate how they deploy knowledge, incentivize people, the whole journaling process changes dramatically? Like 10 years from now, where do you think?
Yeah. So first of all, for academia, 10 years of time is not much time, right? So not much can change in only 10 years, right? But so I would say there's always place for academic research for fundamental research, right? Because there's just very little incentives for anybody other than universities that are publicly funded to do this very important fundamental work that is not having applications, but yet extremely relevant for everything that builds on top of it, right? But at the same time, I do hope and I do see that there will be significant disruptions to the way that research is carried out today. And I used to joke, when we had this ICO craziness in 2017-18, that one silver lining for me is that there's now these kind of crypto projects that have so much money that they are funded for fairly fundamental research and development for a longer time in a more sustainable fashion than many universities are. Because if you think about it, like when I quit my postdoc, one thing that I had to spend significant time on is funding, right? So you have to write these grant proposals, you're being evaluated on that, and then you get some money. It's a little bit really like in a startup world, right? So that's why, you know, people who are in academia and thinking about making the leap to a startup, it's not so different. Like you're writing this grant, like on the other side, you write a pitch deck, right? And some due diligence. Well, in the other world, you're writing your papers and you're getting reviewed on it. It's not so different. So that being said, I do hope that the way that scientific work is being carried out, especially on the publication front, does get way more open primarily and more agile then. Because otherwise, there's just no way that universities can catch up with more agile structures that we do see emerging right now, right? So there is work that is increasingly being carried out outside of universities, which is going to progress way faster. And I think some of the absolutely amazing developments that we've seen in crypto are, you know, an example of that. And maybe finally, I would not say it's just about money. I mean, for me, it was not that money drove me out of academia. It was this thought that there's something that is so fundamentally new, that is so amazingly different, that, you know, this is simply more the bleeding edge than academia could ever offer me.
And how did your skills translate over? Did you see, was HOPR particularly attractive, or the model of HOPR attractive given your background, or did you meet some other people and it became obvious?
Yeah, so HOPR is not how I got into crypto, right? So I got into crypto like many people first through Bitcoin, and then I was actually exposed to Ethereum very early on before it's launched, because I always loved coding. Like I always, since I was a teenager, like the one thing that I always absolutely loved doing is coding, whatever it is really. And now there was this absolutely new paradigm of coding money. We can code a lot of things, right? We could code microcontrollers, we can code computers, we can control robots, like all sorts of things. But something as abstract as money, we could never really code. We could code the access to money, but you could never code money itself. I could code a smart contract that would hold money in and by itself, no matter what happens to me, right? And that was something that was so mind-blowing to me. And I was like, okay, this academia was fun, but I'm going to drop it and go there, because that is just so weird and so crazily powerful that I want to get all in.
Yeah. And so it was SONECT the first project that you worked on?
Exactly. So that was a project I actually co-funded with Rick, who's now again working with me at HOPR. Our paths diverged in between and now came back together at HOPR. That was actually a fintech that we co-funded in 2016. That was basically if you look at SONECT today, it looks like a very traditional fintech. It allows you to do cashback, avoiding kind of bank rails. You have a mobile app for that. Started in Switzerland and is growing in a bunch of other countries right now, not just in Europe, but also in Mexico, UK, and a bunch of other places. So, but the early version, like the first version that I built for SONECT, was actually built on it might sound funny now, but it was like a private blockchain. So that was this 2016-17 meme of, you know, private blockchains are kind of like the intranet, right? So in the 90s, people were selling intranets because the internet was too scary. So that was kind of what we tried, right? You couldn't bring blockchain to banks because blockchain started with a B, just like Bitcoin, and that was evil. So it had to be a private ledger. And so we had actually a backend version that was built on this ledger until we realized that banks were really, really not interested in any innovation whatsoever. And that fintechs would be basically the only thing that keeps banks from just collapsing and dying already. So, and when I realized that, just how entrenched that system is, you know, I still remember this one meeting, how I met some chief architect from some big bank that was very important. And we finally had this meeting, you know, and then this guy would not even tell us how the API is structured so that we could implement it. It's not that I would be able to steal money. It would not be even the thing that we would actually integrate it. Like, he would not even tell me how this thing is structured such that I could prepare the code. And that's just so weird and just so broken in my eyes that was the final straw for me to say, okay, this new world of crypto, which is again building on free and open source software ideology, is unstoppable. And it will certainly, overcome this closed-mindedness that I have first-handedly observed in a legacy financial world.
Yeah. Yeah. It seems like there is a pathway now that is proven in the call it the money world. Like, it's not fintech or crypto, but both together. And you can't, I haven't seen any crypto companies offering banks a solution that they're paying for and that work. And so you either just build a competing system, or you innovate on the existing model and compete with the banks directly. But either way, banks are, I mean, it's not a great future if you're a bank, that's for sure. Especially if you own a bunch of physical locations and expensive retail locations across cities. It's like, I don't know, man. I'd rather be a decentralized, well-funded crypto project spread all across the world with smart people.
Yeah, the brain drain is real.
Yeah, so
we can see that.
Was it a pivot out of that, or did you shut the project down?
No. The project is still live and doing well, but I was personally getting out in order to get really all into crypto. Like at that point, I realized, well, fintech is great, and there might be fintech companies that are doing great and that will be doing great, but that's not what I want to spend my life on. I want to spend my life on building new technologies and seeing the final frontier, right? Seeing where can this stuff take us?
Yeah.
And seeing, having seen how powerful it is, I really wanted to get all in. Got out of SONECT and actually,
Can I ask you, how did SONECT, if the SONECT couldn't sell into the banking system, what did they end up pivoting to, or how did it end up finding traction?
It does integrate with banks by now, which was a long and arduous path to actually get there, and applaud all the people who worked extremely hard to get there. So the they call it ATM as a service model of SONECT is doing really well and works pretty well. Integrating with a bunch of major banks out there. But again, if you compare that path to how crypto grows in the meantime, I would say, well, I'm happy to be in crypto now, and let other people take care of the fintech.
Gotcha. So what's HOPR? What's the inception for you?
So after SONECT, I was working basically educating people on blockchain, Ethereum specifically, and then basically building a service company that would code whatever was needed in the Ethereum space. So smart contract development, tokens, ICOs were very popular for a while. And what I realized is that it's cool that everybody talks about decentralization. And actually, why decentralization? So when I joined the crypto space, it was in the Bitcoin only times. There were only Bitcoin, and everything else was shitcoins. That was kind of the narrative in 2013, 14. And but one thing that struck me back then was, what is this really all about? This whole crypto movement is about empowering the individual. It's kind of freedom technology that sets us free from providers such as banks, such as states who dictate money and some decisions upon us. So if it's basically this whole movement is about empowering the individual, then decentralization is cool and it serves its purpose. But decentralization alone is not enough. We need something else for resilience, and that is privacy. And on the most fundamental level on the internet, you're sending information from A to B. And the very way how we send information around in our digital age is revealing a whole lot about us that is not privacy respecting. So it became then clear to me that we do need a privacy foundation for this kind of new wonder world that we're building here. And that's what HOPR is about. On the most fundamental level of transmitting any sort of data, we need privacy.
So when you think privacy, what surface area do you feel is most relevant to users?
So
Like where are people interacting with this?
yeah, so basically whatever we do today in the crypto world, we are transmitting information. For example, transactions, right? So when you send a Bitcoin transaction, an Ethereum transaction, an NFT, whatever you do, you're really sending data around, right? And you're sending, typically people send data around from a wallet to some provider that can process this data, right? That runs, for example, a Bitcoin node. And by doing so, you reveal a whole lot about you, for example, to your internet service provider. So your ISP learns what you're doing there. So they know exactly at what moment you were sending a transaction. They know how big the payload was. Even if it's end-to-end encrypted, we always think, oh, end-to-end encryption is fine, right? When we start WhatsApp, it tells us this conversation is end-to-end encrypted. All fine, right? Well, no, not really, right? Even if that were the case, your internet service provider as an intermediary learns a whole lot about your activities, your activity patterns, and potentially even who you're talking to. So that is quite revealing. And that is something that needs to get fixed. So any sort of data transport where we transmit data such as transactions, such as, even if it's something completely different, chat messages, think about IoT devices. We do need privacy for sending data around that do not reveal where we're sitting right now, who is sending data to whom, if we don't want to reveal that, right?
And you're thinking when you say ISP, that's the level of privacy that is most relevant here. It would be like the Verizon or the pipelines having access to the data that websites I'm using, time of day. I imagine it's all the metadata.
Exactly.
Primarily.
Metadata is the exactly right keyword. I would not say like that one piece of privacy is more relevant than the other, but I would say if the most fundamental piece of technology that we're building upon is not privacy enabling or privacy respecting, then we cannot really get much better. So we need to fix that layer and everything that comes on top of it. And I'm very happy to see that privacy starts being on people's radar more and more. So we see extremely smart and talented and happily, I'm happy to say, well-funded teams that are solving privacy on the application layer, right? So there's a bunch of teams looking into private computation. That's amazingly important, right? So how can I process data? So you give me data, I can process it for you without me knowing what data I'm actually processing here. So that's one area that's actively developed and I think is tremendously important. There is then all this vertical of on-chain privacy, right? So how can we make blockchains, which are fundamentally transparent, which is sometimes described as a feature, how can we make them private? So initially we've seen Zcash and Monero, just to name two names, and now there is layer 2 solutions on top of Ethereum, such as Aztec Network or ZK Money from Metro Labs being developed that bring this privacy to the transactional interactions that we see on blockchains. All of them are important because privacy is only meaningful if it's holistic in the end. So many puzzle pieces have to come together for us to use this magic internet money in a safe way that is ultimately actually empowering individuals and not just going in a really radically broken direction, such as CBDC, right? Central bank digital currency is the exact counterexample of that in my eyes. Central bank issued digital currency can be used to ultimately control individuals. I can seize all your assets at the blink of an eye, right? I can observe, monitor, and surveil every single step that you take with your money much, much better than with physical cash, where I don't really know what you're doing with that physical cash, right? So I would say CBDC is an example that goes exactly in the opposite direction. And therefore, we need to have technology that really allows people to have safe and privacy respecting ways of transacting in the digital world.
And if and when this gets rolled out, this CBDC probably mandated currency that people use in countries. Is this do you see Hopper as a layer that sits underneath or on top or somehow integrates with it all
So
to
first of all,
prevent the transparency?
First of all, I hope that CBDC never happens. I hope that truly
Yeah, amen.
First of all, I hope that we do manage to build functional, decentralized forms of currency that are stable, but not issued by a central bank. And that being said, if and you know, whatever form of money does evolve, I do hope it is privacy respecting, and a privacy respecting form of payment would use something like Hopper when it comes to transacting and sending data transactions around. Yes, that is one great example, actually.
Mm. So on the homepage of Hopper, it says the private internet for everyone. How does Hopper specifically who are you talking to? Who are your customers, basically? How does Hopper get implemented into the world?
So first of all, for context, Hopper is early on in its journey. We've achieved a early first version of our network, which you can check out, which I'm very happy about. But we're now working on making Hopper useful. So typical examples for me are crypto transactions, right? So if you're using Bitcoin, Solana, Ethereum, you name it, today, you're revealing much more about you than you're aware of. So actually, we made this little tool called DERP. We call it Dumb Ethereum RPC Provider. Maybe we can share the website afterwards, called derp.hoppernet.org. We can actually see what does your wallet reveal and leak about you. It's kind of interesting. So you can really see, like, on every single request, even when you think you don't do anything, like your wallet is broadcasting much more about you than you know. It's kind of entertaining. So
how does that work? Where would it be broadcasting? Like, technically, is it broadcasting it?
Yeah, that's a great question, right? Because why should my wallet broadcast stuff if I'm not even using it, right? Is it spyware? No. So how does a wallet actually work? If we look at a crypto wallet, like what does that do? It's basically showing you a number, typically of your balance, right? It shows you that you have, I don't know, 0.1 ETH. Where does it get that number actually from? It gets that number from a server, right? And that server runs an Ethereum node. Of course, you should run your own, but let's face it, most people don't. Yeah. So your wallet is basically querying, okay, how much money do I have? How much money do I have? How much money do I have? In order to query that, what does it need to send to that server that provides the answers to that? It needs to provide
identity.
Exactly. It needs to send your Ethereum address or your Bitcoin address, your Solana address, whatever it is, right? And in that case, this server learns actually two things that it can trivially link. That is your IP address, which is basically a digital representation of your home address, and your Ethereum or Bitcoin address, which is your bank account. So now somebody knows where you sit and how much money you have and what you do with that money. So if you thought that data harvesting on the Web 2 world was bad, this is going to get a whole lot worse.
Can I ask you a question? That it's not people. The server would be the only person or the only access point to the IP, or is that accessible to everyone, or just the server?
That's actually a very interesting question. It's interesting because today, in fact, it is the server, right? So in case of Ethereum, the most popular wallet is called MetaMask. What is the default provider for MetaMask? It is Infura, right? So Infura sees all that information about you. Now, how's this going to evolve going forward, going into the future? I mentioned initially that everybody's thinking about privacy. Everybody's thinking about decentralization without having privacy in mind. Now, where does that lead us? That leads us to great projects that are trying to decentralize this server, right? So that server that provides answers to your wallet of, for example, how much money do you have? So in the future, if we're going on this trajectory of decentralize everything and have nothing else in mind, there will be decentralized networks of these, we call them RPC providers. So these RPC providers are these servers. And in such a decentralized network, it could be exactly like your question suggested. It could be anyone, right? It could be anyone who's around you who learns that information about you. So that's why we think that in order to be really powerful and safe, actually, a decentralized world needs privacy and needs fundamental privacy solutions like HOPR in order to be safe. Because otherwise, I might be that guy that knows that you're online and I'm really interested in what you're doing today. So I'm spinning up a bunch of these RPC providers which are around you. I'm kind of interested in, hey, what is he doing there? And there's a multitude of kind of Web3 infrastructure that is aiming to be totally decentralized. So there's another project which I find really great. It's called the Graph, right? And the Graph is a network that provides on-chain data and makes it accessible to you. Because actually querying a blockchain is kind of cumbersome, right? So you have hundreds of gigabytes of data that you need to process just because want to get some specific piece of information. So the Graph makes that accessible. Now the Graph has just announced that they are to fully decentralized. But what does that mean? That means that your wallet, as it's querying, or your app, let's pick a popular app on Ethereum, for example, Uniswap, a decentralized exchange, right? So on Uniswap, you want to swap token A for token B, and the information that you're fed from that will come in the end game vision through some decentralized network. Now, you don't want some dude on the internet to know all the information that you're getting before you even have it, right? Because that's an obvious attack vector. It is, again, data harvesting 2.0, and we want to prevent that.
When you that last point there, I want to better understand when the Graph moves to a completely decentralized structure, the data that you're sending and receiving on Uniswap, for example, because they're decentralized exchange, are you referring to the IP address and the address like you were before? And that's now available to everyone because it's decentralized. The Graph is decentralized.
Yes, but it's much more than that. So if you're thinking about it, let's think this use case through, right? So I am swapping, for example, on Uniswap, I'm swapping Ether for HOPR tokens. What happens when you do that in this, decentralized worldview? I hope that Uniswap will use the Graph because I think it's a great project. So basically, you choose the two tokens, and it will show you the price. How does it get the price? It gets the price through the Graph. But what it actually means is your computer is sending information to some Graph node saying, hey, I would like to know what is the price in HOPR per ETH, right? So there's a bunch of indexers out there that take this search query from you, looking for the answer and delivering it back to you. But that means now they learn of your intent of what you're going to trade. And I assume that you're a whale. So, maybe with that information, I can do a whole lot. Let's say there's somebody buying a huge amount of some token. What's going to happen? Well, price is going to go up. What am I going to do if I'm pretty confident that the price is going to go up? I'm going to try to front run you, right? Because I can make profit in that way at your expense. So that is an example of how a decentralized system is allowing anybody to harvest data from you if we implement it naively, and B, how that data can be used to extract value off you. So, and I think that kind of nicely shows that we do need to bring privacy into such a system, such when you use decentralized infrastructure, such as Uniswap working with the Graph as an example, but there's many more. We do not reveal who you actually are, because that's very private information that is of nobody's concern, right? You don't want to reveal to some dude on the internet where you sit right now, how much money you have, and what you're gonna do with that money in the next minute.
Yeah, that seems like such. I mean, the example you gave two examples that seem to be striking. One is the IP address linked to your home address, so someone could directly see not only your past transactions, but also the requests that you're making for information to a server or to a decentralized system like the Graph that anticipate what you're going to make. The second point that you made that's striking is the front running, that if I'm making a request from my IP address and that is decentralized on the Graph, everyone can see that and thus anticipate that I'm going to make this trade. does the graph does Uniswap currently use the graph, and is the graph currently decentralized, or they just announced that they're going to do this? So this is gonna be a problem in the near term.
So first of all, Uniswap uses the graph for some interactions. I'm not sure for what exactly they're using it, but they're using it for some things. I think it's more for the info page this far. And the graph today is somewhat centralized in that people use this hosted service, and it's going through like some proxy that they have in the middle, right? So basically, I don't send data. I don't send like a query to you. Let's assume you run a graph node, right, to make money by delivering data to Sebastian. But actually, it's going like through a proxy that they operate and then to you, because then I trust them. But I hope that they are not just gonna exploit me. Now, the trust assumption is kind of shitty and not what we want not what we're aiming for in this Web3 world, right? So I find it very laudable that the graph is aiming for that, just like many Web3 infrastructure projects are aiming for total decentralization, which is great and powerful. But again, only if combined with sufficient and adequate measures of privacy that protect the users and the providers. Because maybe you as a graph node operator, you also don't want that people know where your graph node is, and maybe you even get attackable by that.
Yeah, it seems to me that given that this is a complex solution, a complex problem that you're addressing here, if I'm just going to explain this to my mom, it's not. It would take a conversation to get the ideas across. When you describe it as the IP address, it's so easy to understand. It's like, well, your IP address is the access point to the internet. That it's your address, digital address, as you say, and that alone tied to your wallet address and having that being visible on the internet, that concept alone is so simple that are there other things? Is the IP address like the 80-20 rule? Is the IP address like the big thing that we have to make private, or
it is
or
the
are you
big
thinking
thing?
about?
But there's also more. I give you a very simple example. So in crypto, people happen to be increasingly anonymous. Right. And, there's really great people that are intellectually contributing to the space, which are not showing their face like I do, but they choose to remain anonymous. And I think I also love this space for respecting that. Right. And that's great. Now, there's many people who have this pseudonym, and we don't know who's behind that pseudonym. Now, if you happen to operate, your clear text wallet that is known to some people, and then you have your pseudonym operating under a different Twitter account and unlinkable and whatsoever, it is very easily possible to link these two. And that's pretty catastrophic. So to make matters worse, I would say, what happens when somebody, leaks a private key? You lose some money, right? And that's sometimes really painful and really bad. But typically, financial losses, you can overcome them. But loss of privacy is something you cannot overcome. Like if it leaks that, I don't know, let's pick some Twitter account like Degan Spartan, right? If it turns out who is Degan Spartan and it turns out it's Mark Karpeles or whatever, like that is something you cannot recover from, because that's information that is leaked, it's public. That is something you cannot recover from. So that's why I think these privacy leaks are actually even more catastrophic than security leaks.
So how does HOPR work? So you're having, you clearly identified and described the problem. Is HOPR how do you view HOPR's infiltration into the internet? Is it a alternative structure to the ISP provider, or what layer do you see? How do you see it? What's like the product roadmap?
I sometimes explain it to people. You can see HOPR like a VPN 2.0, right? Maybe VPN 3.0. So why do we use a VPN? We use a VPN so that the website that I'm accessing doesn't see my IP address, right? So for example, when I access a website, I don't want that website vendor to know where I am or be able to link it to other things. I route everything through that other server. But what do? Like by using a VPN, we 100% trust that VPN provider. And more often than not, it turns out that they actually do log you, and they do log everything that happens to your connection data. And actually, you reveal your entire browsing history, all apps that you're using, all connections that all your apps are making in the background, right? That is all adding
to a VPN.
Yes, like if you use a VPN, that VPN is
Wow.
like, it's everything is routed through that VPN. So basically, you now have one central provider, a VPN provider, who can build a perfect digital fingerprint of all your activities. And that's pretty messed up. And if you think about it,
Yeah, and they're just storing this on it's completely centralized, right? So I'm picturing
exactly.
NordVPN just because they have a lot of advertisements. They have servers somewhere where they're just storing all this information
So
about
here
their
it gets
users.
interesting. Like the more legitimate providers tell you that they don't log anything about you. And that's a complete hoax. And there's a very simple reason for it. Let's say you have a VPN provider. It comes with some terms, right? So, for example, you can use it with two devices in parallel, right? Now, how would they know that actually Sebastian is already using his mobile phone and his laptop already, so he can't use another laptop? They know that because, at least short term, they do store information and process it. And it is simply a requirement to enforce their terms of service.
Hmm.
So VPN providers at all times, at least on short time scales, do log connection data. Yeah, so if they store that long term, maybe the more legit ones don't. But then again, what do they do if a court order comes, right? So, well, probably they do log you and they do reveal that.
Yeah, you want to be using a service that can't access your data, not that they choose not to, or that they just say they're secure and they won't give it to other people.
Exactly, exactly. So ideally, you want to use a service that cannot log you, right? So as sometimes people say, like the Web 2 with Google, branded it itself as "Don't be evil." The Web 3 is "Can't be evil."
Right.
So how can we build a VPN that can't be evil? That's what Hopper is. Instead of having one central provider, we are actually having a network of many providers. And instead of your information just going through one hop, which is that VPN server, the data in the Hopper network is hopping. That's kind of where our name comes from one node to a next, and thereby obfuscating where information came from and where it goes to. So we entirely unlinked the sender from the recipient of data packets.
That's fascinating. Entirely unlink the sender from the data packets. How
The
can you?
sender from the recipient of the data packets, yeah.
Right, right, right. And is that so? If I'm picturing myself, I'm a computer. I'm sending a request out there to a server, another computer.
Yep.
You're the hopper in between. So So am I actually sending it to a server that Hopper runs, and then that gets
That's Yeah, that's exactly right. So you would send it basically to a Hopper node. And that Hopper node is what Hopper is not just this packet relaying infrastructure that I mentioned, but what Hopper does in addition to that is basically, it's also called a mixnet, because each of these Hopper nodes are mixing up packets within other packets that they get before they send them out. So you basically get this completely mixed up traffic, and you cannot link incoming and outgoing packets anymore, which is really powerful.
hmm.
And by doing so, by mixing up packets and by hopping them through several intermediate relay nodes, you are obfuscating where it came from and you're obfuscating where it goes to. So even if you are like a passive adversary that can see every single packet on the whole internet, you would not be able to link the packets that went through this mixnet like Hopper. So it's a very strong privacy guarantee in such a network.
Is that an incrementally more difficult or like significantly more difficult route to trace? I mean, I'm still picturing it as I'm sending a request to a server maintained by Hopper. Hopper bounces it
Yeah.
around and then sends it out. Does it just make it practically much more difficult to trace the transaction, or is it? like theoretically impossible.
It it makes it extremely much harder. Now,
Yeah.
one thing that you said, which I want to pick on, is you said if it's operated by Hopper, right? So if it's operated by Hopper, well, you would have to trust Hopper, right?
Mm-hmm.
But in fact, Hopper, so we don't operate these nodes. The nodes are run by a diverse network
I
by our
see.
community,
Right.
right? So the interesting thing here is that you don't have to trust us whatsoever, right? So first of all, Hopper is free and open source software, so you can look at what it does. And secondly, anybody out there can run that software, and you can, as you choose a path through that network, you can basically verify kind of who is like from where running these nodes. You build a path through that network, and thereby you are kind of obfuscating for any third party out there, like where data come from and where it goes to. And then in your example of sending data to a server, so you take the data packet, you send it to the first Hopper node, operated by Alice. Alice sends it to Bob, Bob sends it to Charlie, and Charlie sends it, for example, to a graph node, right? So this graph node only sees, oh, I got a packet and it comes from Charlie, but I have absolutely no idea where that packet actually came from.
I see. I see. So can I think of it like, does this metaphor make sense? So you have, I'm in a car and I want to drive from LA to San Francisco to ask them a question. And I know where I want to go and I have that information in the car. Maybe it's on the window. And but I only have a direct, that my first stop is like, uh, somebody's house, and I stop there and they tell me to go to the next house, next house, next house. And I might make 7 or 8 different stops before I finally get directed to San Francisco because I'm using the Hopper network. So if someone were to try to trace where I came from, they'd have to go through each of the different stops along the way to backtrace that. Is that roughly, does that make sense?
That's roughly. That makes sense. Let me take this analogy and make it one step closer to what we actually do. You're actually passing through like a bunch of train stations.
Mm.
And you enter the train station, and along with you, there's a whole lot of other people, entering the train station. And there's people leaving the train station. We can't see what's happening inside the train station. We only see there's a whole lot of humans coming in and a whole lot of humans coming out. And in addition to that, while people are in the train station, they're changing clothes, right? So you come in your blue jacket and you're going out like in a black jacket. And like, you come in like with a like red backpack and you're going out with a like leather suitcase.
Mm.
So this transformation and mixing at every individual stop that you're taking along the route makes it super hard for somebody who's tracing even all these individuals that are running around there, like who's who and where they're going.
That's super interesting. And let's talk about timeline a little bit, and team size. You guys have raised some money for this project. Roughly how much have you raised and how many people are involved in this now?
Yeah, so Hopper is currently a team of 18 people developing this protocol. I mean, not all of them are obviously developing, so we also have some community team
Mm-hmm.
and some communications to explain this kind of complicated stuff to the world. So to date, we as Hopper Association has raised $5.5 million. And in addition to that, Hopper had a token launch, and a token launch was a little over a year ago. And if you're looking right now, Hopper has a Uniswap pool. So the entire funds which were collected from the community were going to a Uniswap pool. So Hopper Association extracted zero value from that. That is, a launch of this token was carried out by the community. It is liquidity that is entirely managed by the community, so by the Hopper DAO. And that happens to be right now on Uniswap v3. And that uni pool has currently, I have to check the exact number, I think somewhere around $10 million in the pool right now, in addition to the funds that we as Hopper Association raised from VCs.
Interesting.
So the funds that we raised were from VCs. And in addition to that, the community did this token launch, and it's governing this pretty deeply liquid Uniswap pool.
And so I imagine you set up a private company, you raise money from investors investing in the private company to develop the protocol. Was the mechanism for the fundraise from investors prior to the token launch, was that investors selling discounted tokens, or was it for equity in the company developing the protocol, or some other combination?
Yeah, this is typically the part that is kind of tricky in crypto, right? So how exactly do you set it up, and what exactly do you raise funds for? And we don't see a gold standard yet. So here's what we did. So first of all, Hopper is free and open source software and will always be. So actually, the mothership of Hopper is not a private limited company. It's actually an association. So association is a little bit similar to foundations, especially here in Switzerland. They're very popular. So I think per capita, Switzerland has the highest number of associations, and people use it for anything from, local soccer clubs to like some local communities, all the way to like pretty large organization that happen to be organized as an association. So an association does not have shares, which kind of bodes well with our free and open source software spirit. So there's no value extraction and an alignment between all parties. So there is no IP, hence there is no equity of any value, and hence we also don't have any shares. So investors that financed the early development of this protocol invested actually in tokens. So the lead investor of our seed round is Binance, or the venture arm called Binance Labs. And Binance and everybody else invested in the Hopper token, which we then launched at the beginning of last year.
And so the Binance token or the Hopper token was launched. Binance participated in that. How does the DAO structured? So the DAO takes 20% or some percentage of what was raised initially and manages that capital?
So what? No. So this is kind of interesting, right? So we have this kind of initial institution which kind of launched the token, which hired a bunch of people. I'm one of them, in which launched the token, which sold it to VCs. And then we basically said 8.5% of the final total distribution is hereby allocated to you, the community, and you can launch and decide upon it however you want to. And this was kind of a pretty big leap of faith. However, we had built a pretty loyal community that really helped us in the early development of this network, testing with a series of test nets where we had several thousand people participating. We had a bunch of games that we did there. So it was really like a very, very cool, very loyal community. And they basically decided that they would auction off these tokens. So what actually happened is that, first of all, some tokens were sold to those early testnet participants. So that was around 3,000 people who could buy $800 worth of tokens each. So there was quite some capital coming together. And from that, an auction was launched. And in this decentralized finance world, there's like really great protocols that allow you to do that in a very easy way, in a permissionless way. So the community was then setting up a balancer pool. So balancer is also a sort of decentralized exchange for launching such auctions. And these funds is what the DAO is managing. The DAO was then recently, for example, saying that from the trading fees, they were sponsoring bounties at a hackathon. The DAO was also saying that they want to do some liquidity provisioning incentives. So these are things that the DAO is governing and managing.
Interesting. I appreciate you explaining that. I always love asking about the structure because, like you said, there is no gold standard. So it's interesting to hear how different projects structure incentives when they both raise money from investors and also launch the token. Are you active?
It's difficult, yeah.
Yeah.
It's difficult because there is no, if we talk about shared corporations, we're building on literally hundreds of years of best practices, right? We have all these kind of standard terms and things that we have here. But when you're then dealing with these crypto networks that, again, don't have this intent of value capture, like crypto networks, many of the successful ones actually have the explicit intent of not having ultimately a legal entity or structure in place anymore, because it should be totally decentralized, which is an unbelievably big change in paradigms of operating some structure of humans that come together to create value, right?
Yeah.
So yeah, it's very new, and there's an incredible amount of innovation happening in this space. So also, if there's people here who are not techies, but people who are interested in organizational structures, into human coordination problems, there's lots of work here, and we're at the absolute beginning and trying to figure how this thing could work.
Yeah, totally. I very much resonate with that. I'm so interested in how, in that latter point, and how people structure themselves and projects and the different categories of projects that there are, and how some structures, funding structures, don't make sense for some projects, but make sense for others, depending on how value is both contributed and extracted from the network, and the degree of risk, and yeah, all sorts of other factors. I love this. I love the Hopper project. You've explained it so clearly, and it's something that seems so obvious when you explain it, that we need in the world. Are you actively writing on anywhere in the internet, or tweeting more about this? We'll have links to all the Hopper stuff in the show notes, but are you personally?
Yes, I also do. So you find me pretty much on all platforms. My handle is SC Bürgel, like my last name. And you can find me on Twitter. I'm really pretty interested in thinking about, thinking about a lot of directions, not just, but also on the privacy side. And yeah, I would say Twitter is the best platform to engage. We also do write pretty actively on Medium. That's where you can find us as well. So I'm personally on Twitter and pretty actively engaging in a lot of topics, because maybe one last field to come back to what we talked about in the very beginning. Coming from the academic world, it's all kind of closed-minded. You sit in your little university and then you go to conferences. Here in crypto, we have Twitter, right? You can engage with anybody. If you have a great idea, you write about it, people will engage and take it to the next level. So I'm very happily contributing to this ecosystem of people that are thinking in the open.
Yeah, it's awesome. Well, thanks so much for sharing your story, and congrats on all the progress you guys have made. Hope to have you back on someday, Sebastian.
Thank you so much for the opportunity to talk about privacy and what we do at HOPR here. Awesome. Thanks so much, and all the best.
Take care.